So we'll continue our review now onto functions. We're going to evaluate f of x if f is 7. So x squared minus 2x plus 1. So f of 7 is 7 squared minus 2 times 7 plus 1. Okay, order of operations says we have to do that exponent first. So that's 49 minus, and we've done the exponent so we can multiply 14 plus 1. A lot of times people just forget about this minus and do 14 plus 1 and say it's 49 plus or minus 15. Be careful about that. That's a negative 14 plus 1. Maybe safer if you just go in order. We can add and subtract left or right. 49 minus 14 is 35, plus 1 is 36. Okay, evaluate g of 3 minus x. So this 3 minus x is going in for x. So that's 4 times 3 minus x squared minus 6. So you can rewrite that 3 minus x as 3 squared as 3 minus x times 3 minus x. Or we can use the shortcut we usually use in class where we do the first term squared, then double the product. The product here is negative 3x. Double that is negative 6x. And then the second term squared, plus x squared. Okay? So this in parentheses comes also from 3 times 3 is 9. Minus 3x is minus 6x. And negative x times negative x is positive x squared. Distribute the 4. So we've got 9 times 4. And then negative 6x times that 4. And then 4 times x squared. Okay? And then we'll combine our like terms and we'll put it in descending order. 4x squared minus 24x, and then 36 minus 6 is 30. Okay, evaluate g of x minus f of x and find the domain. So that's 3x over x minus 5 minus x plus 12. In order to subtract these, we must have a common denominator. That common denominator is going to be x minus 5. So we need to multiply by x minus 5 over x minus 5. So we've got 3x minus x squared minus 5x plus 12x is 7x. And we should keep this second part in parentheses. Minus 60. Okay, so this negative applies to everything in the parentheses. So we've got a negative x squared. Well, that is all over x minus 5. Then we've got a negative x squared. 3x minus 7x. And negative 60 is positive 60. Now we need to find the domain, and when we add, subtract, multiply, or divide, our domain has to satisfy the two original functions and our composition. Here, there's no denominator, there's no radical. X can be any number in the world, that's all real numbers. Here, our denominator cannot equal 0, which means x cannot equal 5. And here again, our denominator can't be 0, so x cannot be 5. So the only restriction for our domain is that x cannot equal 5. F of x divided by g of x. I'm going to go ahead and put f of x over 1 and divide that by g of x. Okay, so our shortcut is to multiply this outer loop. And we've already multiplied x plus 12 by x minus 5 and gotten this right here. So that's x squared plus 7x minus 60. And the inner loop, we multiply those to get our denominator, 3x times 1. Again, adding, subtracting, multiplying, or dividing, our domain has to satisfy f of x, g of x, and the composition. So reals, so no restriction there. X can't be 5, so we know that's one restriction. And here, this denominator can't be 0, and 3 times 0 would give me a 0 denominator. So x cannot equal 0 or 5.